One of the things that is a part of ecosystem ecology is the flow of energy through ecosystems. Now, in previous videos, we talked about energy coming from the sun as supplying the food chain through photosynthesis, and we pick up on that again here. Now, productivity of an ecosystem has to do with how much energy is converted by photosynthesis. So we have the GPP, or gross primary productivity, which is the total photosynthesis rate. We have to subtract what the plants and other organisms are going to use in respiration, R for respiration, and what's left over is the NPP, or net primary productivity. So if we're talking about plants, only the net is available for herbivores, not the gross. Now, here we have a diagram of what's known as an ecological pyramid. We can look at pyramids in several ways. Let's say we're going to look at a pyramid of energy. So we have to look at ecological efficiency. Now, here we have sunlight energy being converted to plant biomass in producers. Only 1% of the energy is going to make it to plant biomass. So we're talking 1% efficiency rate between sunlight and plants. Consumer levels are about 10% efficient each. That is, 10% of the energy here is going to make it here, and only 10% of this is going to make it here, and so forth. So you see how this pyramid of energy rapidly diminishes as you move up the levels of consumers. Now, let's say you've got 1 million kilocalories of sunlight in a given area. Well, you're already down to 10,000 kilocalories here, 1,000, 100, 10, and 1 per that same unit area. Now, we can also look at a pyramid of biomass. If we were to do like grams of dry weight, it would still look like this. There's going to be more biomass of plants than there would be of herbivores. There's going to be more biomass of herbivores than the carnivores that eat them, and so forth. We can also plot a pyramid of numbers. It takes a whole lot of plants to feed so many herbivores, and so many of these to feed so many of these, and so forth. There's a lot of implications of this. Regardless of whether we're plotting energy or biomass or numbers, the trend is the same. Lower trophic levels outnumber, outweigh, and have more total stored energy than higher trophic levels. Well, top predators are already going to be in the lowest numbers. Top predators need a large amount of undisturbed land area to even have a modest to support a modest population of top predators. If there's any ecosystem disturbance, all of this gets reduced, and these guys are going first. So they're already in the lowest numbers, they're already the most vulnerable. So this is an overview of energy flow.